Hello, welcome to today's screencast, and we're going to be looking at the energy continuum. So, if we just have a quick recap on what you've done before in your energy for exercise and the energy systems section of the course. So, a quick look down from here. So, first up, then. We've got our energy systems that we had a look at: ATP-PC, glycolytic and aerobic system. We made sure that we could kind of apply the following key points to each of those energy systems. So that was our first thing. Now what we have to do, and we're not starting a new topic, this is actually a continuation of looking at these energy systems, but the key focus now is we're going to have a look at a visual representation of these three energy systems in action. And that visual representation is called the energy continuum. So if I show you the picture now, what we've got is the energy continuum here then. So you can see here the ATP-PC system. And what you've got down here is the time in which it kind of works for. So you've got kind of anywhere from 0 seconds up to 10 to 15 max, okay, will be the red one here. So it's working at almost 100% intensity, and it will slowly go down towards 10 to 15 seconds. As soon as that happens, it flips over. The systems switch. Okay, so then the system that becomes predominant goes into the anaerobic glycolysis. Now, what we know that as is glycolytic system for our specification, which is over here. So the glycolytic system kicks in at about 10 to 15 seconds. And then from that point, it's still at a high intensity. As you see from here, it's looking always up to between 70, kind of 90%, maybe up towards 100% at times. And that then works from 10 seconds to 3 minutes. All of this stuff you've been taught, okay, when we're talking about the energy systems. Then, following that 3 minutes, I mean, as you can see here, the aerobic system, which is the green one, works to an extent during the glycolytic system, or during that time period here, up to 3 minutes, but it's not predominant. It becomes the predominant system, the highest contributor, from 3 minutes up to kind of 5 hours, which we've talked about for things such as marathon. So when you see about this energy continuum, all it is basically saying, here's a graph with the percentage kind of capacity, or how hard each energy system is working, and the time. The time's the easiest bit to do because we kind of know roughly which system goes from where. So looking at that, that's that. Well, what does it actually, how do we describe it? You don't have to make notes on this now, okay, because you have this repeated on your first slide. So the first thing we'll look at then is this. So the relative contribution of the three energy systems. That's what the energy continuum is. It's the relative contribution of the three energy systems. Now the relativity part of it is kind of justified or dictated by the predominant energy system being dependent upon the intensity and duration of exercise. So what that means is, I'm sure you can work it out. If it's a high intensity, low duration, then you're looking at ATP-PC. If it's still a high intensity, but the duration goes above 10 seconds and up to 3 minutes, you'll come down to your glycolytic system. And then finally, if the intensity is particularly low to moderate, and it's a high duration, e.g. up from 3 minutes up to 5 hours, then you'll be using your aerobic energy system. So this is how this is the descriptions of it. But like I said, hopefully I've just given you the picture, showing you what it is. You would need to draw this graph. Okay, this graph is important, and we also need to make sure we've got the descriptors, which we'll come on to in a future slide. Okay, so let's have a look at the specification then. So specification on what you're required to learn, okay, is you have to know the predominant energy system during different types of exercise. The key focus is going to be how intensity and duration of exercise influence which energy system is predominantly used to resynthesize our ATP. So that's what we just had a quick look at there, and I'll show you in your next slide. And then this bit we'll have a look at in the lesson, how you interpret figures relating to the percentage contribution of each energy system. And we'll also have a quick look at this, the interplay, how energy systems switch between each other during kind of intermittent exercise, so when the exercise intensity alternates pretty quickly. So we'll have a look at that as we go through. We'll also have a look at these other factors in the lesson on what dictates which energy system is used during these kind of intermittent exercise things. So if we go on from here then, if you have a look ahead, the kind of thing, some of you might be thinking, well, how's this going to look in the exam? So if you've got an energy continuum question, you probably wouldn't get the graph, but this is the type of thing you might get a question on. So explain what the energy continuum is, and justify the position of one sporting activity, or it could say action, on the energy continuum. Now that is a one question there. So what we'll have a look at is, if you have a look at that, maybe at the end of the screencast, you go back and have a look, see if you could do it. Okay, so that's an example of question, a lower order question, but certainly a question nonetheless. So let's have a look then. First part then. First thing on that question, it said describe the energy continuum. Okay, so the energy continuum then, here's your picture, you've got it here as I said before. The energy continuum then, this is the key thing, you have to have these 2 bullet points as your description for them. Nothing else will do. So the energy continuum refers to the relative contribution of 3 energy systems. Now, this relative contribution basically means that the predominant energy system is dependent upon these 2 key terms here, the intensity and duration of exercise. Now, I'm pretty sure we've kind of looked at this when we've looked at each energy system. I'm pretty sure people will feel quite confident with this already. Now, there's one thing I just want to make a point on here, and this is just like a key note, okay? You're not going to get a mark for describing it, but it's a key point nonetheless. So if we have a look at it, the thing that we have to try and get ahead is energy systems. When you're taught energy systems at the start, you might start to think they're discrete and they work on their own. They don't work in isolation. They are constantly interacting with each other. One works for a bit, the other one kicks in, depending on the activity, of course, and then another one comes in, the other one doesn't work as much, and it's constant. There's a constant interaction between the systems in different activities. So we'll have a look at that as we go through. So there's your first slide. Make sure you've got those in. You need a diagram. You need these two here, and this will be just a start point, just to make sure to keep your brain ticking. They don't just work on their own. Okay, in some activities. So let's go from here then. Let's have a look at our kind of key focal point then. So the first thing you have to be able to do is using a sporting action, or knowing a system, you have to be able to link it to the intensity and duration of activity. So this could be a question that comes up in your exam. Explain how intensity and duration of exercise influence which energy system is predominantly used to resynthesize ATP. So let's have a look then. So starting off, ATP-PC system then. If you were going to look at this now, I'm pretty sure you'd be able to give these 2 terms some context and link it to the system, hopefully giving an example. So what I'll do here then is ATP-PC system then is predominant. It's the predominant system when exercise is high intensity and the duration is between 0 and 10 seconds. And a good example of that is a shot put there. It could be, like a 100-meter sprint, okay? Might go up towards 15 seconds, but that still can be just about inside the thing. So shot put there, discus, long jump, high jump, all of these things that are kind of really high intensity, but durations below kind of 10 to 15 seconds. Next system then, okay, is glycolytic system. So the glycolytic system then, is still, when it's predominant, is when the exercise is high intensity, but the slight difference is the high intensity actions tend to work from 10 seconds onwards, usually up to 1 to 2 minutes, but at a maximum up to 3 minutes. Okay, so an example here could be something like 400-meter sprint, okay, or 800-meter sprint. Okay, so these kind of things where people are running at high intensity, but not quite as high intensity as this. So that's kind of your thing on there. Hopefully you feel like that you remember this from kind of energy systems lessons. Finally then, the aerobic system. How does that link to these 2 terms? Well, so let's have a look then. So the aerobic system is predominant when exercise is low to moderate intensity, and the duration will be somewhere from 3 minutes plus. Okay, so we're looking at kind of a marathon run in this situation. So hopefully that makes sense. That's your first section. This is kind of the kind of specification objective, which could turn into a question. So just make sure you feel confident on that. We've got to be able to link intensity and duration to each system, and then give an example to justify specifically why we think that system is predominant. So that's that. Now, what I've done here is I've kind of contradicted what I said on the slide before, because what I've done is just give you specific sporting actions from athletics that are used to use this system pretty much predominantly. What we're going to have a look at now is the next bit, which is the next part of the kind of specification. Says, can you explain the interplay or interchange of energy systems during intermittent exercise? So you might want to just kind of make sure you've got that as an objective title, and then if we go from here, I think it's really important you have a kind of understanding of what intermittent exercise is. So there's a description of it. Intensity alternates. So for example, this could be during something like interval training, when you have a work and rest periods or work relief period. So when it's the kind of exercise intensity extremely high when you're doing your kind of work period, but then it might lower when you're doing your relief period. And finally, and the other example of this, of course, is during what a lot of you will be kind of familiar with, invasion games. Okay, so invasion games such as football, netball, or rugby. And I've put rugby here. We'll use that as our example. So the thing you might have to do in the exam is you might have to give examples. So the question might say, using a team game of your choice, explain the predominant how energy system or predominant energy system will switch. Okay, so that is something that you might get in your exam. So when you're doing this, you have to be able to consider the following 3 processes in order to ensure you get the marks that are required. So you must be able to give an action or a skill from within a invasion game. So we're using rugby here. Then you have to link it to the system that you think will be predominant for this particular action. Then you have to justify why. So what I'll do is, if I give you down from there, if we go on first up, we have a rugby tackle. Now the rugby tackle, okay, as we all know, would use, well, hopefully you would all know, would use the ATPP system. The key reason why is because the action of a rugby tackle is extremely high intensity. Okay, so put down to here, so extremely high intensity, explosive, and let's just cut that off there, and anaerobic. Okay, so it's an anaerobic action that does not require oxygen. So that is why the ATP, that's why you're justifying it, because we've got to keep linking it to that intensity process that we talked about before, and then give some, like in other sense, for example, it's explosive. It doesn't require oxygen. PC can be used straight away to do that. Hopefully that makes sense. Then, if we flick over to something else with an invasion game, we could put a recovery sprint. Now, a recovery sprint I've used because that can be used across all invasion games, but you could say something like a hitting multiple rucks at a breakdown if you're doing rugby, for example. A recovery sprint, let's say, for example, a team has run forward for a long kick, the ball's turned over, and a player has to sprint back. Now, that system, the system that is predominant when you're doing a recovery sprint, is going to be the glycolytic system, because once you've done that, okay, so that movement, so say for example here, that the recovery sprint involves changing direction at a high intensity, and it's also an anaerobic action because you cannot get oxygen in to make the aerobic system predominant. If you think about a recovery sprint, say you run forward 5 seconds and then you have to turn around and sprint, you're probably looking at, I don't know, say 50 yards to get back for a high ball over the top. You're looking at that then lasting in that, it's an extremely high intensity run, and you've gone forward, then you've run back. That takes you into that period of the glycolytic system, okay, because obviously it's above 10 seconds, but it's not going to go beyond 3 minutes. Okay, so that's that one. There's the action there. Finally, let's say after the ball goes dead in rugby, for example, then walking back to position. Okay, so walking back to position. Now, straight away, when you're walking back to position, that is an example of the system that will be predominant will be the aerobic system. Why? Because walking back, extremely low intensity action, which is aerobic, which allows you to get your breath back, which allows you to breathe. That process there then is going to be aerobic. So hopefully you can see how you would give 3 different actions and then link them to 3 different systems, but justify using intensity and maybe whether it's anaerobic or aerobic to kind of justify why you think that system is predominant. So that's kind of where I need you to be. They're the 2 objectives I want you to look at. If you can make good notes on that, making sure you've got your Cornell notes set out for the 2 objectives, that'll be absolutely great. Okay, thanks very much.